All right, guys. We're going to complete the 4.7 lesson here. So if you haven't watched the first little bit, make sure you go watch that first. That way, hopefully some of this stuff will make a little bit more sense. But essentially, we're talking about inverse functions. And so on example 3, they said describe the end behavior. I debated even going through this example because we've done end behavior so many times. But I figured it doesn't hurt. It's quick. So they said we're going to describe the end behavior for tangent inverse of x. So what I need you guys to do is visualize what that graph even looks like. So let's kind of just sketch that really quick. It doesn't have to be fancy. But the tangent inverse, it has these values on the y of just negative pi over 2 and pi over 2. And it's going to go through the origin and scoop up and scoop down. So it's going to look kind of like that. Now, what's important is seeing where the asymptotes are, so we know exactly where this is going to not reach. It's approaching those, right? Which is really what end behavior is going to ask us to figure out. So we're going to write our limits for end behavior, where we're talking about what's going on the left, what's going on the right. So on the left side of our function, we're going to write a limit, right? So on the left side of your function, think about what's happening on the left. As you go to the left, your x's are approaching negative infinity. So you don't even have to write that this is the left side, right? Because this part right here takes care of that for you. It says you're on the left. Then tangent inverse is approaching, the limit. So it's getting closer and closer to, on the left, it's getting closer to negative pi over 2. Yeah, that's a negative. All right, what about on the right? Again, you shouldn't have to say left or right, because the way we write the limit should make that clear. On the right side, your x is approaching positive infinity. So indicate we're on the right side. We say it approaches infinity like that. And I'm going to say tangent inverse of x. So the limit, as we go to the right, our y's are approaching positive pi over 2. And that would be our end behavior on the left side and the right side. Okay? All right, I got a little bit more for you guys to get copied down. I'm going to try to get all this on the screen. This is all that I have left for us, is these examples and that little bit of notes. So what you're seeing here is us talking about when essentially you're able to just straightforward cancel your inverses with the normal function. So like sine and sine inverse, I'd be able to cancel if you have this scenario here. I'm doing sine of sine inverse. You see the order: cosine of cosine inverse, tangent of tangent inverse. In those situations, it's just going to cancel. So that it shouldn't be something that you're having to like look really closely for. Whereas in this scenario over here, where our answer is supposed to be the sine inverse, right? We're doing sine inverse of sine of x. So our final answer may not be what x originally was. You may not just be able to straightforward cancel, because all of the outputs for sine inverse should be from negative pi over 2 to pi over 2. All of the answers here would need to fit in that range as well. So this, you have to watch out for that restricted interval that you are working with there. So when we've seen some problems like that where we weren't just able to just straightforward work it, we had to kind of find a equivalent angle. It's not a super duper common thing for us to deal with. Most of the time things cancel out, but this is still something we got to watch out for. All right, let's look at these examples here. So we're bringing algebra into it. And a lot of times when people see these for the first time, they get really nervous. But I don't want you guys to like get yourself too overwhelmed. I promise these are not that complicated. All right. We have all the tools we need to solve it. You just may not realize that yet. So we're going to go through this process on part A. It says we're doing cosine of x plus the square root of 3 equals negative cosine of x. All right, I'm seeing x is in more than one location. So my first impulse is I need to get my x's together. They can't be separate and me solve it. So we're going to get them together in one thing. So I'm going to add a cosine on both sides. I'd prefer to work with positive values as much as I possibly can. So I'm going to add cosine of x, and that just cancels. So that's no longer a thing. The other thing I can do, and I can do it in the same step if you guys like to do 2 steps in one, you can definitely also go ahead and move this constant, because if I put my x's on the left, I need to put my constants on the right. So we're going to move this square root of 3 so that would be gone in there. All right, let's see what we have. When you add cosine of x plus cosine of x, that's going to make 2 cosine of x's. And the root 3's are gone here. The cosines are gone over here, and we're just left with the negative square root of 3. Okay. All right. So now from here, we're going to need to, we have 2 times cosine of x. We're going to need to divide by 2. And that gets our cosine of x all by himself. All right, so now you've got to ask yourself on the interval that they told us, that's the whole unit circle, where is cosine negative root 3 over 2? You can go to your unit circle, cosine negative root 3 over 2. I'm looking for my x's. Where are my x's? Negative root 3 over 2. Oh, I see one here. 5 pi over 6. All right, over here, 7 pi over 6. So 5 pi over 6 and 7 pi over 6 are my answers. All right, let's do another one. A lot of times people look at this and there's 2 things that are scary. They see this theta and they're like, oh my gosh, what do I do? Okay, guys, you straight up can replace that theta with an x and it works the exact same way. So that's all this is a variable. Okay, don't worry about it. The other thing people see is that sine squared and they're like, I don't know what to do with that either. So just as like I don't know, a notation type of thing. Sine squared is the same thing as if I had sine theta times sine of theta, right? People just you don't write it as sine theta squared like this, because then that looks like you're squaring the angle. That is not it. We do put the squared with the sine part, and that is what indicates we're squaring the whole, like the sine part times the sine part, not just theta times theta, okay? All right, so that's all that means. We're going to go through solving this guy the same way that you should solve every algebra problem. You want to get your variables on the left, your constants on the right, or just whatever's easier. In this case, I think variables on the left is easy because they're already here and they're already positive, so I just think that it's good to stay there. So I'm going to leave the 4 sine squared theta, but we're going to add that 3 to bring it over here. All right, so last time I did all my inverse functions in that red color. I'm not going to do that always, okay? I may write here just so we can see that. So I've got 4 times sine squared theta, so I'm going to divide by 4 so that that's gone. So really we have sine squared theta equals 3/4, and then you're going to solve from there. This is being squared, just like we've always done. Like if you had an x squared, right, you would square root both sides. I'm doing the exact same thing here, so I'll show that part too. You're going to square root. Don't forget your plus or minus, because that is a something that could mess you up. And when you square root here, you are left with sine of theta equals plus or minus, right, square root of 3 over square root of 4, which is 2. So you're going to tell me everywhere on my interval, everywhere where your sine or the y value is positive or negative root 3 over 2. There's actually 4 answers on this one if you're looking at the entire circle. So let's look. So we're looking positive or negative square root 3 over 2 for the y coordinate. I see that here at pi over 3. I see it at 2 pi over 3. Those are positive root 3 over 2, but remember negative as well. So we're going to be down here at 4 pi over 3 and 5 pi over 3. Those are all of our answers. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Ta-da! All right, we got a couple more equations we're going to solve. They're going to include inverse operations, so we can see how that comes into play. All right, so let's look at the next thing. And hopefully, sorry, I'm trying to move my stuff so we can see this a little bit better. Okay, so we have some inverse operations we're going to solve, or we're going to inverse trig functions in our equation here we're going to have to solve with. So, debating getting a new piece of paper. I think this is okay though. Let's use the back of that. Okay, so for these problems, all right, we're going to start with A. Here we have 2 times cosine inverse of root 2 over 2, and that's equal to sine inverse of x. Now, here's the thing, y'all. I know we have 2 different inverse trig functions, and I know that that can look a little scary, but we have just done a whole lesson on how to solve inverses. Okay, cosine inverse of root 2 over 2, you're asking yourself where on your unit circle, where are your x's root 2 over 2? So we're going to go on your unit circle, and remember how for cosine, we should only be looking from 0 to pi, so the top section of your unit circle. So to keep in your brain those ranges, for cosine inverse, we're looking at the top part of the circle, 0 to pi. So, and we want to know where is it root 2 over 2 for your x coordinate there. That's right here at pi over 4, right? All right, so we're going to replace that part, which is pi over 4. And then over here, we have sine inverse of x. All right, 2 times pi over 4 is going to give us pi over 2. Right, same thing as like 2 times a fourth, it gives you a half. So 2 times pi over 4 is pi over 2. And this is equal to sine inverse of x. All right, so here comes the cool part. All right, now some of you guys may be able to like undo this in your head without like seeing this other way. I don't know, but something that can really help is, do you remember how we said that as long as we had sine of sine inverse, these things should just cancel out and it not be a problem. So I want you to look at what we're going to do here. We're going to do a sine on both sides. The beauty of that is the sine and the sine inverse will in fact cancel. So it's no longer an issue. And then what we're left with is you are figuring out what is sine of pi over 2. That is what's equal to x. So go on your unit circle, look at pi over 2, look at the y value. The answer is 1. Ta-da! Okay, one more, guys. Here is part B. All right, we have a similar situation. We have 2 different types of inverse functions. We did include a pi on here, so it might feel like it's uglier, but it's honestly not. Because, again, x is only inside one of these guys. It's going to make it easier. Now, this guy has a solid value. If you look for tangent inverse of 0, you're asking yourself, on its interval, where is your tangent 0? Well, remember, tangent is y divided by x, sine divided by cosine. So if you're looking on our interval from negative pi over 2 to pi over 2, the right side of your circle, I need where my y value is 0. Since tangent is y divided by x. If y divided by x equals 0, I need y to be 0. That's how that works. So look for where is y 0. Oh, hey, looky here, at 0. Remember, the interval is supposed to be from negative pi over 2 to pi over 2. Okay, 2 pi doesn't fit in that, but 0 does. So we're going to say 0. Tangent inverse of 0, hey, that is 0. And then we can deal with this guy over here. All right, we are going to do cosine on both sides. Boom, gone. So I need to figure out what is cosine of 0. Nope, not theta. 0. That is equal to pi x. All right. So look at 0, figure out what is cosine. Hey, at 0, my x coordinate is 1. Cosine of 0 is 1. That's equal to pi x. And then you can solve for your x value by dividing by pi on both sides. Therefore, x is 1 over pi. Ta-da! Okay. Guys, we've made it through, right? Do you have a review for your test that has some practice problems like this on there? So please make sure you begin working on that and ask questions when you have them. But I will see y'all later in the next chapter. Bye.